Now we're going to start our unit on systems of equations, and today we're going to focus on solving those systems by graphing. So a system of linear equations is a set of two or more linear equations containing two or more variables. The solution to this system is going to be an ordered pair. Now, given two lines, there are three possible outcomes. Outcome number one, there's one solution, in which case your lines are intersecting exactly once. Option number two, there are infinite solutions, meaning both of your lines are the exact same. And then option number three, there are no solutions, which happens when both of your lines are parallel because they're never going to touch. Parallel lines do not ever intersect, so you won't have any solutions there. So just to give you an idea of what these will look like, if there's one solution, maybe here's a line, and here's a line, the solution would be wherever they intersect, so this solution would be at the point 1, 1. If we have infinite solutions, maybe here's a line, and here's the other line. They're literally the exact same line. They overlap perfectly. And then finally, no solution might be, here's one line, and here's the other. They're going to have the exact same slopes, they're parallel, so they will never intersect. In these examples, I'm going to give you a point and two equations, and we need to check and see if that point is a solution to these two equations. In order to do that, we're going to substitute each value of that point into each equation and make sure that the equation stays true. So in number one, our point is 3, 1. First, we're going to put it in the first equation, x minus 3y equals negative 8. So our x value is 3, minus 3 times our y value equal to negative 8. So we have 3 minus 3 equals negative 8, 0 equals negative 8. This is not a true statement, so we already know that this point is not a solution. It doesn't even work for one equation, so I don't even care if it works for both. Now in number two, we've got the point negative 4, 1/2. So let's substitute those. Negative 4 plus 6 equals 4 times 1/2. Let's see if this is true. Negative 4 plus 6 is 2. Half of 4 is also 2. So far, so good. We work for the first equation. Let's check the second one. 2 times negative 4 plus 8 times 1/2 equals 1. 2 times negative 4 is negative 8. 8 times 1/2 is 4 equal to 1. Negative 8 plus 4 is negative 4, which does not equal 1. So it worked for the first equation, but it did not work for the second one, so this is not a solution. Here I'm giving you graphs, and we need to see if they have a solution, and if they do, where that solution is. In number 3, the blue line and the red line intersect, so that means they do have a solution. That solution is at that point of intersection, which is at negative 3, negative 1. In number 4, so far it looks like they're not going to intersect, but I want to check just to make sure. So to check that, I'm going to find the slope of each line. If they have the same slope, they are parallel, which means they will never intersect. So let's check that slope. For the blue line, we went up 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5, 6, 7, 8, 9. So the blue line has a slope of negative 4 over 9. Green line, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. They have the exact same slope, which means they will never intersect, so there are no solutions. You might also see it like that. NS for no solution.